My name is Krishna Danaji Kashid and I am from Automobile Department, and my paper presentation on optimization of process parameter in electrical discharge machining. Now let's start with abstract. The abstract is that it is non-traditional machining process. I have three input parameters and fixed parameters. In this project, the surface finishing point of the material is very important to find out. We use D3 stainless steel material and brass wire. Now let's keywords. These are the keywords which we are focused on these following topics: Taguchi method, gray relational analysis, ANOVA analysis. Now let's start with the introduction. In this non-traditional machining process, in electrical discharge machining, we use wire electrical discharge machining type of machining process. We choose D3 stainless steel material and we have brass wire. 65% of copper and 35% of zinc is used in brass wire. The brass wire is an alloy of copper and zinc. The diameter of the wire is 0.25 mm, and the Takuji optimization technique is a single parameter optimization based on the signal to noise ratio. Gray relational analysis is multi-response analysis, and statistical analysis of variance is performed to see which process parameters are statistically significant. In the design of experiment, we use 3-level array, which is orthogonal array. In orthogonal array shows the number of rows and number of columns and number of inputs and the number of levels in the table. There are 3 levels. Each level contains 9 readings. There are total 27 readings. T on means pulse on time, T off means pulse off time, SV means servo voltage. These are the inputs, and the unit of this is microsecond, and voltage is voltage. Now let's start with the Takuji optimization method. Takuji optimization method is optimize single performance characteristics, and the output of the Takuji optimization method is signal to noise ratio. The surface roughness should be minimum, curve fit should be maximum, and the material removal rate should be maximum. We use these two formulas as per minimize and maximize condition. There are 3 graphs here. One graph is plot against signal to noise ratio of surface roughness and the output of the surface roughness, and same with curve width and material removal rate. Gray relational analysis. There are 4 steps: gray relational normalization, gray relational gathering, gray relational coefficient, gray relational grade. Normalization, there are 4 to 5 formulas as per the steps. In the first normalization step, the normalization value shows between 0 to 1. In the ANOVA, analysis of variance, is statistical based objective decision making tool for detecting any difference in the average performance. Analysis is factor. This is levels. In the DF means degree of freedom, SS means sum of square, MS means mean square, F value means ratio of this, P value means least one pair of means. conclusion is that shows the readings that shows optimum surface finishing point. Thank you.